be on the slide. I want it until I click. And there we go. So hopefully everybody can see my first slide with the guy with the peace sign, the hippie with the peace sign, the headband, because today we're going to discuss mean, median, mode, and range, and they're all tied together. These are all what are called measures of central tendency. And they're one part of statistics that allows you to analyze a group of data, a bunch of numbers, and find the middle, or most reasonably find the middle number that represents all the numbers. And there are the three most common measures of central tendency are the mean, the median, and the mode. And that's what we're going to talk about today. We'll go a little bit further with median and look at a different way of visualizing data too. But these are the basic three that we're going to discuss. So now I'm going to put a definition up here and some examples. The mean, and that's probably the most common way of measuring central tendency. It's the average of a set of data. So when most people say what's the average height or the average weight or something like that, the average price, they're usually talking about the mean. And to calculate the mean, you can find the sum, which means you're adding all the data numbers up, all the data points up, and then you divide by the total of things or the total of numbers that were in the data points. So then we'll have some examples. Okay, so for all of these numbers, I don't know if you have access to a calculator. I know one person's in the car, so you probably can't do this, but if you can, I would recommend that you try some of these either now or later, just practice them. I find that practicing some of these problems before you present them to students, then sometimes you can see the mistakes they make because maybe you made them yourself. But excuse me. But for this set of data points, 12, 15, 11, 11, 7, and 13, you're going to find the sum of the data. And of course, the word sum, if you're describing this or defining this to your students, you would want to go over the vocabulary word. What is the sum? The sum is you're adding everything up. So that's the first thing you do. You find the sum of the data. So we're adding them all up and we get 69. And then you look to see how many data points, how many numbers you added to get that 69. And we can see that there are 6. So we then divide by the number of data, which is 6, and we get 11.5. So for students who are studying for their GED, going to use a calculator for the majority of the GED. So I'd encourage you to have your students get familiar with the GED calculator. It's the TI-30XS, but it's always nice for them to know how to do it without a calculator. It's good for their mathematical brain. And it's there are some problems on the GED test that do not allow a calculator, but have them get comfortable with the calculator. As long as they're okay adding and dividing, it just speeds up the process. Okay, so the mean is 11.5. Okay, then they have a little memory device. I don't know if it's going to help, but you can remember that mean means to average because the mean teacher averages your grades. You try the next one. That's an obnoxious sound. I don't know if you can hear it. And then another example, an electronics store sells tablets at the following prices: $350, $275, $500, $325, $100, $375, and $300. What is the mean price? And again, we're going to find the answer on our own before checking the answer that's given by adding everything up, coming up with $2,225, dividing by the number of data points, which is 7, and getting $317.86. So the mean is, of course, 317.86. The next type of measure of central tendencies is the median. And the median is the middle number in a set of data when you order it or arrange the number in numerical order. So that's always the first step when you are locating the median of a group of numbers, is you have to rearrange them. Sometimes they are given in order, usually not. And so that'll be the first step. So on a test, if a student's given a group of numbers and they're asked for the mean, they don't have to order them. They just add them, divide by the total. But for the median, they're going to order them so that they can see what's in the middle. So the same set of data points, an electronic store sells tablets at these prices. What is the median price? So the first thing to do is place them in order. So you're going to start with the lowest to the highest, and then the price in the middle is the median. So in this case, we have 7 data points, 7 prices. So with 7, there is one number in the middle. It's not always like that. Sometimes if you have an even number of data points or prices, there won't be one number in the center. But in this case, there's one because it's an uneven number of numbers, an uneven number of numbers. And the median is located, it's 325. Now for another group of values, which will show you an even number of data points. This is an example there, 12, 15, 11, 11, 7, and 13. When you arrange them in order, you see that there is no central number because there are an even number of values. So what you do then is you find the average of the middle 2 numbers. So you're finding the mean of the, even though you're looking for the median, because there isn't a true median in the middle, you're finding the mean or the average of the middle 2 numbers, which are 11 and 12. So when you add 11 and 12, you get 23. Dividing by 2, the answer or the median is 11.5. So it's not actually one of the numbers, it's in between 2 of the numbers. And then the third way to average or find the measure of central tendency is the mode. And the mode is the number that occurs the most. It is the most popular. So when we have a group of data points, the mode is 11. You can see it right away. Sometimes you have to put the numbers in order so that they all line up. But in this case, you can see there's only one number that occurs more than one time. And sometimes a set of data will have more than one mode. For example, in the following set, the numbers 5 and 7 appear twice. 5 and 7 are both the mode. And this set is said to be bimodal, 2 modes. One of my students yesterday said, what happens if you find 3 modes? And in that case, I assume, I didn't look it up, but I assume that would, that data set would be considered to be bimodal or trimodal. This is bimodal. With 3, it would be trimodal. And sometimes there is no mode in a data set. So in this example of numbers, you can see there is not one number that occurs more than one time. So on a test, if the choice was find the mode of these numbers, and one of the choices was there is no mode, then that would be the correct answer, because there really is not. You can remember that mode means the number that occurs the most, because mode and most sound alike. Okay, so for these numbers, what is the mode? You can see there is no mode, no mode. And then, as I mentioned in the beginning, we're also going to talk about the range. The range of a set of data, it's the difference between the largest and the smallest numbers in the set. How big is the range? Sometimes it's huge, sometimes it's a very narrow range, because all the numbers, all the values are within a very short span of numbers. For example, consider these numbers, and they're all over the place. To find the range, you would take the largest number, 55, and subtract the smallest number. Now, some students would put these numbers in order first, even though you're not looking for the median in this particular problem. It's helpful to some students if they put their numbers in order anyway, so that they can make sure that they can see the smallest number and the largest number, and then they subtract the smallest from the largest. In this case, the range, 55 minus 26 is 29. So this is the brief summary of the 3 types. Mean is the average. Median is the number in the middle, or the average of the 2 numbers in the middle. And then the mode is the number that occurs the most. Okay, so in my class or classes, I always repeat things multiple times to make sure that it sticks. You introduce it one time and it makes sense, but learning has to be repeated and practiced. Then we have a nice sheet that goes over all of the different types and gives examples, so that they're all, it's the definition and the examples are on the same page. It's a very easy reference sheet for students to look at. So we have mean, and the data sets 2, 5, 9, 3, 5, 4, and 7. And they are added together and divided by 7. And it's an even number or a whole number, which is 5. And then the median, they give 2 examples of the median, which is good because it shows a data set that has an odd number of elements, and that's always very easy to just find that middle number, 5. And the second example is an example where it's an even number of values, and you're averaging that 4 and that 5 that are in the middle, dividing by 2 and coming up with 4.5. And then we have some examples. Oh, it is trimodal. Okay, it's on this sheet. So single mode data set, which has one mode in the middle, but you can see that they have not ordered these numbers. So students would want to place these in order, find that middle number 5. Then we have bimodal and trimodal. The range for the data set below if you put them in order, you can see which one is biggest, smallest, and then the range. And that's a typical test question. What is the mean of a set of data points? What's the range? They need to know those definitions and have practiced them a few times. I don't know if you would like me to pause so that you can try some of these examples, or if you would like me to email these to you. If you want to comment, you can let me know, or chat me to let me know if you would like me to pause right now and have you do a few of these problems.
Why don't you email them?
Okay, email them to you.
Mhm.
Okay, Kathy, I certainly will.
Because that way the numbers are there, so you can see them
Mhm.
and then just fill in the answers.
Fill in the answers. And what I always do, if I give these sheets to students to do on their own, of course, if you're working with them, you want to see their answers. But if you are sending them home or emailing these to students, of course, this is not a test situation, so that they're not cheating by looking at the answers, but that way they can correct themselves. So if they do 2 problems and then they look at the answers and they realize they weren't correct, then they won't do the rest of them wrong. They will look to see what they did wrong. But I always, when I give students worksheets to take home, or once they're done, let them see the answers. And so these worksheets are nice. I got them from Math Aids, and I'll send you the website too. It's a really nice website with free worksheets. You can sign up for an account. A free account has lots of ads everywhere, but that doesn't bother me. I ignore them. The paid accounts do not, but I just use the unpaid account. You can print all kinds of worksheets, and you can go in and you can choose, you know, what number you want. If you want large numbers, small numbers, how many values you want. I limited these worksheets so we didn't have like 30 numbers. Like number 7 has like 9 numbers or 10 numbers, but you could ask for more if you wanted to. But I just wanted to make sure that the students get the concept without, you know, really torturing them. Okay, so those are the
So
worksheets.
for the GED, how much, if they had a problem like this, how many numbers would they likely have in a problem?
I don't think it would be unreasonable because they know that their time is limited. But again, the good thing is they'll probably have a calculator for that type of problem, but it might be worked into a word problem. So it would be nice if they just said, what's the mean? But they might work it into these trees, or if it was a science question, these trees on this tree farm are these heights, and then show a graph of maybe field 1 with all the trees and their heights, field 2 and all the trees and their heights, and then maybe the third field of trees and all their heights. And they might ask a question, so maybe they would give 6 heights or 7 heights. It wouldn't be like 30 heights of trees. And then they may say, for field 3, what is the average height? So the student's going to have to know how to read a table. So they're going to go across to where field 3 is. So they're not looking at the wrong column. They're not looking at field 1 or 2. So they locate field 3, and then they have to know what the average is. And usually when they just say average, it means the mean. If they meant something else, they would ask. If they said, what is the median tree height? Then they would specify that. And so that they would probably not have many more values than 9 or 10. Okay, So we really went over all of the 3 methods and the way to find the range. Depending on the level of your student, you can go a little bit further with median. I like to do some of these workshop or these worksheets with students if they're ready for it and they're not, frustrated with the math. If they're frustrated with the math, and it's nice to stop, give it a rest for the day, revisit it. But if they seem like they're getting it and they're interested, there's a way to go a little bit further with median and create these box and whisker plots. They look very complicated when you see them on paper, but they're really not. And they're very specific steps to finding all the numbers that you need to create the box and whisker plots. So a box and whisker plot is just the methods that we've been looking at before earlier today to find the measures of central tendency. Those have all given us a number. One number that, using one of those 3 methods, represented all the numbers in the data set. This, instead of giving us a number, is going to give us a picture of what the data looks like. So it's a visual representation of data. So for instance, to create a box and whisker plot of this player's points that he has earned in 7 games, what you would do is, first of all, you would order the data. So that's always the very first step when you're creating a box and whisker plot. You order the data, of course, smallest to largest, and then you find the upper extreme, which is the high number, and the lower extreme. And you're not really looking for a range to do that. Like if you were asked for a range right now, you would subtract 32 minus 5 and come up with the range. But right now, what you're finding are 5 different points that you're going to put on this plot. So the first 2 things you find, the highest number, the lowest number. Okay, so we called that the upper extreme and the lower extreme. And then
is there some reason why you would not also tell them that the upper extreme is called the maximum and the lower extreme is called the minimum?
Yeah, I mean, it's always good for students to learn different vocabulary words for the same thing. And I always think it's a great idea. You can say, this is also called the maximum or the minimum. And that way, if they see those terms on a test, they don't get confused. Or sometimes different books will use different vocabulary words. So no reason at all. It's good to introduce them to any words that are going to make things less confusing when they come across these problems. So now we have, for this, we've got the upper extreme and the lower extreme. And then you're finding the median of the data set, and that's 17. So when you ordered these, you found that number in the middle. In this case, there's 1 number in the middle. Of course, if there were 2 numbers in the middle, you'd have to average them and create that median. But we have a nice 17 in the middle. And then you find the median of the upper numbers. So between 17 and 32, I'm sorry, between 18 and 32, you find 20. So between 17, or the upper numbers after 17, you're finding the median. And you're also doing, and you're calling that the upper quartile, and the lower number, the lower median is 10. So you have those 5 numbers are all you need to create this box and whisker plot. We're going to see what, whoops. Okay, so I'm going to show you an example, and I'm going right to what the box and whisker plots look like. And I'm not sure why that other slide disappeared. I'm afraid to go back to it. Hang on one second. Let's see. I don't know where it is. Okay, that slide disappeared, so. But I will send that to you as well. Okay, so let me go back. Okay, so now we are at the box and whisker plot formation. So all of these numbers for these problems that are on the screen right now, they are, and on the worksheets, they're ordered for you because the ordering step, we don't need to do every single time. As long as they get it, then you can show them worksheets or give them worksheets that have the numbers already ordered. So now the numbers are all ordered. For number 1, you find the minimum, which is 1, the maximum 25. You see, Kathy, that they're switching vocabulary words here.
I see.
Mhm. Yeah, so your point was well taken. Always let them know there's another thing to call it. And then we're finding they're calling Q1, Q2, and Q3. Q1 is the median of the lower numbers, and that is 5.5. So you found the median, which is 15, right here. You found that. I'm afraid to click on this because I'll go backwards. You find the median of the numbers. You find the median of the lower numbers, and that is 5.5. And then you find the median of the upper numbers, which is 22.5. With those 5 numbers, you create a number line. The number line will have 5 points on it. So the first thing the student would do is they would create a number line. If there isn't a number line already visible, they would create a number line and they would put a mark on the number line for the minimum, the maximum, that's always a starting place, the median, which is 15, and when you're doing creating a box and whisker plot, they call that median Q2 because they're finding essentially 3 different medians. The first one is Q1, the second one is Q2, and the third one is Q3 in that order. Is this making sense, Kathy?
Yes.
Okay, all right. So you have those. Initially, you just are putting points on the number line. When you're done, you will take those 3 medians, Q1, Q2, and Q3, and you're going to draw a box around them, all the way around them with the median, Q2, right in the center. So what that's going to do is to show you a visual representation of where these data points congregate, where they lie. So for the basketball player, what that would show, and I'll send you that slide as well, what that will show is how is this basketball player expected to perform during a game. It would show that either his box of data would center a little bit lower, a little bit higher, and it would let the coach know how likely is he to score 10 points. In that case, he was likely to score between 10 and 20 points during a game. So then the coach could look at that and determine if he wanted to have him get in the game or sit on the bench. And then Q2 or number 2, essentially it's the same thing. You can see that problem number 2, the numbers tend to congregate a little bit lower. Okay, so then this is just sort of a wrap up that the mean is the average of these numbers. The mean is the average, which is 5. The mode, you can see it occurs twice there. So it's a single mode. We have the middle number, the median being 6, and the range 8 minus 1 being 7. So do you have any questions?